This video is going to cover 6-4 over trapezoids. Okay, so you'll want to have out your hierarchy and then practice 6-4. Okay, what I want you to do is take a look at where trapezoid falls on our hierarchy here. Okay, if you notice, it's directly below quadrilateral, but it's above a parallelogram. Okay, so that means it's more specific than a trapezoid, but not quite as specific as a parallelogram. Now, when we talked about parallelograms, our definition, if you notice on the markings here, we have opposite sides that are parallel. We've got two pairs of parallel lines. Okay, so today we're going to talk about a trapezoid. Okay, so trapezoid is less specific. It only has one pair of parallel sides. And that's our definition. At least one pair of parallel sides. Okay, and you'll want to mark that on your picture here. Okay, I marked the top and the bottom because that's what looks like we've got parallel in this particular trapezoid. Okay, it's just one pair of opposite sides that are parallel. Okay, well, we also usually talk about angles. With our parallelogram that was above, opposite angles were congruent and consecutive were supplementary. Again, it's less specific here. Okay, and if you notice, let's take a look at some of our angles here. None of our angles look like they're the same size. Okay, now, we won't always be able to tell by a picture, but from here, they're not the same size, so we can't mark anything as congruent. So what we need to look at now is supplementary. Okay, supplementary just means two angles are going to add up to 180 degrees. Well, if you notice on the top, you've got two obtuse angles. If both of your angles are greater than 90, they can't add up to 180. Very similarly, on the bottom, those two are both acute. If they're less than 90, they can add up to 180 degrees. However, the pairs of angles that are consecutive between our parallel lines are supplementary. Okay, we're going to call those the consecutive angles between our parallel lines are supplementary. Now, there's no real way to mark that in a picture, so I'm just going to write a little note to myself that I know these two will be supplementary as well as these ones. Now, we normally also talk about diagonals. Okay, I'm going to draw in my diagonals here. Okay, you don't need to, because we've got three options for diagonals to be. They can be bisectors, and if you look at those two pieces, they're not equal, so it's not cut in half, so not bisectors. The other option is it could be intersecting at a right angle. Now, this looks close, but since we don't know anything about these other sides, I really could have drawn my trapezoid way slanted like that, and then my diagonal goes through at not a 90-degree angle. Okay, so it does not have to be a right angle, so we're not perpendicular. The only other option is the whole length itself is congruent. And from this picture, that is a little bit longer than that one. If you don't believe me, you can measure it, but there's nothing special about the diagonals for a trapezoid. Okay, so let's talk about an isosceles trapezoid. Again, if we go back to our picture, isosceles trapezoid on our hierarchy falls directly below a trapezoid. So it has to be a trapezoid, but a special type. Okay, so that's part of our definition. We know that it is a trapezoid. And since it's a trapezoid, we can go ahead and mark our parallel sides. But it's a trapezoid that has congruent legs. Okay, remember isosceles from triangles means at least two sides are the same length. Well, in a trapezoid, it means two sides are the same length, and we'll call these sides legs, just like with a triangle. Okay, so with two congruent legs as our definition. Okay, so let's go ahead and mark that in our picture with tick marks. And then we can talk about angles. Well, there was something special about isosceles triangles. Not only were two legs congruent, two angles were congruent as well. And those were the base angles. Okay, when we're talking about bases, it means the parallel sides in a trapezoid. So the top would be a base and the bottom here. So my base angles would be the top two are congruent to each other, and the bottom two are congruent to each other, but not the same as the top one. So we'll put two arc marks down there. And that's one of our properties for isosceles trapezoids. We've got base angles that are congruent. Now, unlike a regular trapezoid, there is something special about the diagonals for an isosceles trapezoid. Okay, so pause the video and go ahead and draw in your diagonals. Again, diagonals could be three different things. They can bisect, they can be perpendicular, or they can be congruent. Okay, either side of the same diagonal is not congruent, so not bisectors. Okay, again, on this one, we can't really tell the angle here, but it's not a right angle. So the only thing left then is congruent, and that happens to be what these are. If you actually measure them out on your picture, the diagonals should be the same length. Okay, and the way we're going to mark that, since our intersection's in the middle, I want to say that the whole length is the same. Well, that means the pieces have to match up as well. So I've taken care of the single tick mark. I'm going to put two tick marks on the top half, and that's different from the bottom half, so 3. And I'll do the same thing on the other diagonal. 2 up top, 3 down on the bottom. So based on that, we should be able to answer some questions. Okay, 1 through 16 on the front here just ask you to name the shape as specific as possible. Okay, so looking at number 1, we want to see what we are told. Okay, on number 1, the only thing that's marked are sides. Okay, so we're looking for a pattern. If you notice, opposite sides are the same number, so opposite sides are congruent. Well, that tells me it's a parallelogram. The only thing I have to ask myself is, can I be more specific? If you look below parallelogram on your hierarchy, you'll find a rhombus and a rectangle. Well, a rhombus, all sides have to be the same, so it can't be that. And a rectangle, we have to know something about the angles, which we don't. Okay, so we're going to just say this is a parallelogram, because both pairs of our opposite sides are congruent. On number 2, I've got the arrows on my sides, which mean parallel, and I've got one pair of parallel sides. If nothing else is marked in the picture, that's all we know. So we just are going to call this a trapezoid that we learned today, because of that one pair of parallel sides. Okay, I'm going to skip down to 5 and 6, okay, and talk about those ones next. Again, on 5, just sides are marked. And if you notice, all 4 are exactly the same. Okay, see if you can remember which one means all sides are the same. Now, this almost looks like it would be a square, but even if it did look like an exact right angle, unless it's marked, we don't know for sure. Okay, so we're just going to call this a rhombus because of those 4 congruent sides. Okay, the next one looks like above. It looks like number 2 almost, but one more thing is marked. Okay, from above with this parallel sides, I know it's a trapezoid. What I want to know is, can I be more specific based on those two tick marks? Okay, the answer is correct. Yes, I can be more specific because it's not only a trapezoid, but it's an isosceles trapezoid. We knew it was a trapezoid because we had one pair of parallel sides. Okay, so I'm going to give that reason. And I knew it was isosceles because I had congruent legs. Okay, isosceles trapezoid is one of those weird ones where I really need more than one reason to explain why. Okay, what I'd like you to do next is work on 3, 4, 7, and 8. So those 4 blocks to the right of the ones we just did, and see if you can figure those out. Go ahead and pause the video and work on those. Alright, if you notice, number 3, we've got only angles marked. For angles, they can be congruent or they can be supplementary. That's what we've worked with so far. Okay, here we do have congruent ones, but they're next to each other instead of opposite. We do have supplementary ones, but not all 4 sets. Okay, if I look at my top 2, 110 plus 110 gets bigger than 180. However, the side 2 pairs are supplementary. Okay, so this information here, since I have 2 pairs of consecutive angles that are supplementary instead of all 4, tells me that it is a trapezoid. Then on top, those angles and the bottom angles being congruent tells me it's an isosceles trapezoid because of those base angles. Okay, so again, we want to give 2 reasons. Okay, the first one has to do with your 2 pairs of consecutive supplementary angles. Now, normally we say the angles between the parallel lines. Notice nothing is marked here. But by definition, if you have 2 pairs of consecutive angles that are supplementary, and those pairs are across from each other, that means where they're between have to be parallel. Okay, so I'm just going to have you say 2 pair of consecutive angles that are supplementary. That tells us trapezoid. Then the base angles being congruent tells us isosceles. Alright, on number 4 you should have said it was just a quadrilateral. Okay, because we do have a pair of opposite sides that are congruent, but they both aren't. So we just know it's quadrilateral because it has 4 sides. Alright, 7 was one of those tricky ones. You've done one like this before. The information I'm given right now, I've got 1 pair of opposite angles that are congruent and 2 pairs that are supplementary. Okay, but I need to find out what the other missing angle is in order to ask some questions about the rest of it. Okay, so if you add up 110, 70, and 110, subtract that from 360, you will get 70. Okay, remember, you can't just say it's 70. You have to go find it because sometimes it will throw a weird number at you. Okay, but once you see that, we know it's a parallelogram. Opposite angles are congruent. Now, if it's a parallelogram, we also know that opposite sides are congruent. If you notice from the picture, opposite sides aren't marked as congruent, consecutive sides are. So if I know opposite sides are congruent, the top one's 1 tick mark, I can put 1 on the bottom. Very similarly, the left one's got a tick mark, the right one has to too, because opposite are congruent. Now that that's marked, I've got 4 congruent sides. This is a rhombus. for two reasons. Okay, we first had to show it was a parallelogram to know that the opposite sides were congruent. Okay, so we'll say opposite angles are congruent. And then, from there, we found out that there were four congruent sides. Alright, the next one, diagonals are marked. Three things diagonals could be are bisectors, congruent, or perpendicular. Okay, bisectors will show up, both halves of the same diagonal will have the same tick marks. That's true. Okay, so we know so far that these are bisectors. Okay, in order for them to be congruent, the entire length will have the same number of tick marks. We got 2 on that one, 2 on that one. So they are also congruent. So I just have to check perpendicular. It doesn't look perpendicular, but it's not marked, so it can't be. I need to look for what figure has congruent bisectors. Okay, congruent bisectors comes on rectangles. Okay, so we're saying that the diagonals are congruent bisectors. And remember, I don't really care what order you put all the words as long as you get all that information in there. Alright, take a look at the next four. I've got 9, 10, 13, and 14. Okay, 9 is a little bit tricky, okay, but if it stumps you, skip to the next one. Pause the video and we will talk about them to make sure you've got them correct. Okay, I said 9 was tricky. I'm actually going to talk about 10 first, and that'll help me explain what's going on in number 9 here. Okay, we have 3 right angles marked, but you can find the fourth one by taking the 90, 90, 90 and subtracting that from 360. Okay, you have to have a right angle there. Okay, so we know that this has to be a rectangle because we've got 4 right angles. Again, you want to make sure you can't be more specific than that. The only thing more specific than a rectangle is a square, and we don't have all the side marks. So we're going to stick with rectangle for the reason 4 right angles. Okay, so over here, I'm going to talk about 2 right angles. Now, that doesn't give me enough information to find these, but it does give me enough information to know something about these 2 angles. If I take my 360 degrees and I subtract off 90, subtract off 90, I'm left over with 180 degrees. Well, I know 90 plus 90 is also 180 degrees. So that just told me I have 2 pairs of supplementary angles. Okay, and that's always going to be the case for a quadrilateral. If you know that one pair of consecutive angles are supplementary, then the other pair opposite have to be supplementary as well. Because if you take 180 out of 360, you're always left with 180 degrees. Okay, so that tells me that this is a trapezoid because I've got 2 pairs of consecutive angles that are supplementary. Okay, and that's what we'll use as a reasoning here. Now, once again, what this means is I've got the same distance between these 2. Those sides are parallel. Now, if you can recognize that 2 pairs of two pairs of consecutive angles that are supplementary mean that the opposite sides that they're between are parallel, if you mark that with an arrow, you could also use the reason 1 pair of parallel sides. So if you mark in the picture your parallel sides, you can use that as a reason instead of this. Okay, I'll let you do that. Okay. On the next one here, again, we were dealing with angles. Those are supplementary. Since that's the case, we know that it is a trapezoid, but our top angles are not congruent, so we can't also call it isosceles. Okay, so we're just a regular trapezoid because, again, that two pair of consecutive angles that are supplementary. Okay, we couldn't have these be supplementary as well, so not a parallelogram. Opposite angles aren't congruent. Trapezoid's all it could be. Alright, hopefully this one screams square to you, but we have to be sure. We've got 4 right angles and 4 congruent sides. It is a square, and those are your reasonings. 4 right angles and 4 congruent sides. You have to have both. Alright, taking a look at the next one. 11, 12, 15, 16. Pause the video and work on those. Number 11, we've got opposite angles that are congruent. That's a parallelogram. Missed some letters there. Now, 12's a little bit tricky because I see a right angle. Okay, so I know that my diagonals are perpendicular to each other. Well, that tells me it could be a rhombus or a square, but if you notice, for both rhombus and square, not only are they perpendicular, but they're perpendicular bisectors. Now, a bisector, if you remember, means each side of the same diagonal have to be the same length from the intersection. That's not marked here. And if it's not marked, you don't know for sure that those are bisectors. So we can't call it a rhombus. And if they're not bisectors, we can't call it a parallelogram either. Okay? As of right now, based on the information we're given, this is just a quadrilateral. We're going to come back next time and talk about what this shape is. Okay, 15 was the same as number 7, I think, so we don't need to do that. Okay, let's talk about the diagonals going on for number 16. Okay, we're checking 3 things again. Are they bisectors? Are they congruent? Or are they perpendicular? Okay, I could get rid of perpendicular because I don't see anything marked. Congruent means the whole length is the same. Well, that's 8, and the other one's 8, so yes, they are congruent. Now, are they bisectors? Okay, so is this part of the diagonal the same as that one? 5 and 3 are different, so they're not bisectors. So I'm looking for just congruent diagonals. Okay, just congruent diagonals are what we talked about today. Okay, that is an isosceles trapezoid. This is the time where it's okay to just use one reason for isosceles trapezoid when you're talking about the diagonals. Alright, on the back side we've got a trapezoid here, and specifically if you look at it, that entire length is the same as that one. This is an isosceles trapezoid. Okay? If you notice also, there's this length in the middle that we haven't talked about. Okay, this is called the mid-segment or the mid-length. You have a little bit of space above these problems, so go ahead and write the mid-segment. Or mid-length. Okay, the mid-segment is in the middle of the 2 bases. And it's actually the average between the lengths of those 2 bases. So you can find the length of a mid-segment by taking 1/2 of the first base plus the second base. And we'll just call that B1 plus B2. So let's use that to solve for z here. Okay, we're taking 1/2 of the first base, which is 14, and plus the second base, which is 20. Remember, the bases are the sides that are parallel to each other. If we take 14 plus 20, that's 34, and half of that is 17. Okay, so our mid-length or our mid-segment is 17. Okay, the next one, we're looking at y, and we talked about this. Our left-hand side and our right-hand side are congruent because they have that same number of tick marks total. So we can set those equal to each other. 5y plus 5 equals 15. Subtract that 5 over. And then just divide by 5 on both sides. So we've got our y being 2. Last thing we have to look at is x. Notice in our picture, x is an angle, so we have to think about what we know about trapezoids' angles. Okay, these are consecutive angles, and consecutive angles we know are supplementary. If they're supplementary, they have to add up to 180. So I'm saying 78 plus that x better equal 180 degrees. So I'm just going to subtract that 78 to get 102. 18 is very similar. Okay, to find the mid-segment, we're going to take half of the basis. So 4 plus 8 is 12, and half of that is 6. In this case, our mid-segment is y, so I'll put 6 there. Okay, go ahead, pause the video, see if you can figure out for x and z. For x, we've got 2x equals 10, since those are congruent. So x equals 5. Now, these ones weren't marked congruent, but if this is a mid-segment, it cuts each of them in half. We're going to assume this is an isosceles trapezoid here. And since it is a trapezoid, because of the parallel sides, I know that once again, those two should add up to 180. Same numbers, so z has to be 102 degrees again. All right, on number 19, we're assuming this is a parallelogram. Normally, I will tell you what each of these are because we can't assume anything normally. Okay, and this one is a rectangle. Okay, based on that information, you should be able to find all of those missing pieces. Okay, the next one I'm going to talk about is number 21. This is an ideal problem that asks you to find the height of the isosceles trapezoid. Okay, so we're going to go to the right here and mark some stuff before we get too busy getting started here. So isosceles trapezoid means this opposite side is 10 as well. And the height is just the distance between the bases, the perpendicular distance. Okay, so I'm going to mark that with an H. Now from here, I'll be able to find out some extra information, but let's go ahead and start with our ideal process. I is identify what we're looking for, where it wants us to find the height. So what is the height? For part D, we usually draw a picture. Well, they already drew one for us, so I'm going to go ahead and just draw an arrow over to the right-hand side. Now, in order to solve for H, I want to concentrate on this right triangle here. But in order to find H, I need to know the other two side lengths. I've got the 10, but I need to find this distance here. If you remember from our parallelograms, we usually had two heights drawn in. Not only this one vertex to the side, but the other one as well. So go ahead and draw the other height in on the other side. And then we can mark some information. If this top distance here is 8, I know the bottom a portion of the base should be 8 for that part. Now, if the entire length is 12 and I've taken up 8 of it, that means I have 4 left to work with. Since this is an isosceles trapezoid, that means that these two lengths are the same. So my leftover 4, I'm just going to take and cut it in half. I'll have 2 on either side. Now that I have that right triangle, I can set up my E for the equation. To find the missing side of a right triangle, use the Pythagorean theorem. So 10 is my hypotenuse that goes by itself, and then my 2 and my h can go in whatever order I want. A then is act on it. We're going to solve that thing. 2 squared is 4, plus h squared equals 10 squared is 100. All numbers you should know by now. Then h squared, if I subtract the 4 over, will give me 96. If I take the square root of that, okay, it's going to give you a decimal, approximately 9.8. Now, if we want to find it exact, we know we have to break down that radical. I'm looking for the biggest perfect square that goes into 96. Go find that. Okay, biggest one was 16, went in 6 times. Square root of 16 is 4. So if I'm answering my question in a full sentence, I will say the height is 4 square roots of 6, or approximately 9.8 units tall. Then 22 is very similar to that. If you have any questions on this video, just come ask me, and hopefully we can get things straightened out.